Okay, so we are on to 8.2, which is page 3 of your notes. We're continuing on with rates. Now we're solving word problems. So the very first thing is we see a question here where a guy named Jeff lives in Abbotsford, owns a truck with a big, huge gas tank, so some sort of gas guzzler like an F-150, and it requires 135 liters. He can either buy gas in Abbotsford at $1.20 per liter, or in Sumas, which is in the States, for $4.50 American per gallon. Here we're given some extra information, and we are told that there is 3.79 liters in a US gallon. The question is, which option makes the most sense economically, which is the best buy? So there's more than one way to do this, but what I would just do is compare rates from both places. But we have something in Canadian dollars and liters, something is in American dollars and gallons. So we got to convert them to the same rates. So let's convert the Abbotsford rate to American dollars per gallon. So here we go. We know that we are charged $1.20 per liter. First thing we do is we want to change this to gallons. So as we see, we have 3.79 liters on the top, we have 1 gallon on the bottom, and we see that our liters cancel out, and the unit that is left is dollars per gallon. But we still have this in Canadian dollars. So we've got to change it to American dollars. So we start with our $4.548 Canadian per gallon. We got to change it to American. So as you see, we have a conversion factor again here, American dollars versus Canadian dollars. And I got this information from the internet. This is from a while ago, so this may not be the rate right now. But what we see is the Canadian dollars cancel out, and we have an answer left in American dollars per gallon. We compare this $4.27 to the $4.55. We see that this one is cheaper. We didn't need to use the 135 liters. There is other ways to do this, but this I think is the easiest way. So a final kind of statement to answer the question. The question said which one makes the most sense economically, and this is, I think, good enough. The gas in Abbotsford is cheaper. Okay, on to example 2. The question here states that we have a faucet which leaks 1 milliliter per minute, and the question is how many liters are wasted in a week. So what we got to do is we have to change milliliters to liters, and we got to change minutes to weeks. So let's look at how we start. We start with the information that we know, 1 milliliter per minute. And we know that in 1 hour there are 60 minutes. So this is our first conversion factor, and again you should notice that the minutes cancel out. But we want weeks. So next, what else do we know? In 1 day there's 24 hours. So this is again our second conversion factor. We see that our hours cancel out, and we're getting closer to our answer. Next, we know that there's 7 days in 1 week. We have our answer down to weeks, but we have, if you look at what's on the top, we have milliliters. So we got to change our milliliters to liters. So our last conversion factor, we're going to have milliliters on the bottom. So 1 liter is equal to 1,000 milliliters. We see that milliliters cancel out, and the only thing that's left showing as far as units are concerned is liters and weeks. The numbers are still all there, and that's what we need to use for our calculation. So how we plug this into our calculator, everything that's on the top that's important is numbers that are not 1. 60, 24, and 7. We could have on the top 1 times 60 times 24 times 7 times 1, but the ones are not important. On the bottom we have ones and 1,000. So the easiest thing to plug into our calculator is multiply everything on the top in brackets, divide it by 1,000, and our answer is 10.08 liters per week. Example 3. Ms. Dick is asked to order snacks for a staff meeting of 60 people. She decides to order cookies, which come in boxes of 12. She estimates she'll need 2.5 cookies per person. The question is, how many boxes should Ms. Dick order? So, what we have is 60 people or 60 persons. I just wrote it over 1 to represent this as a fraction. Any number over 1 is still the same number, because we were using these conversion factors where something's on the top and something's on the bottom written as a fraction. Okay, so if we have 60 people or 60 persons, we know that each person is going to eat 2.5 cookies, right? So now, as you see, our people will cancel out, or our persons will cancel out. We're also told that in each box we get 12 cookies, so now we see also that our cookies will cancel out, right? If you see everything cancel out, what we have left is an answer in simply boxes. We have 12.5 boxes. If this is a question on a test or something, you may round that up to 13, because you might say that, hey, you can't buy 12.5 boxes, so I probably would accept 12.5 or 13 boxes. Second part of this question says, if each person actually ate 1.5 cookies on average, how many boxes of cookies were left over? So again, let's start with the 60 people. They now eat 1.5 cookies per person. There still is 1 box for every 12 cookies. Everything cancels out. We have how many boxes? After we do the math, we see we have 7.5 boxes. So 12.5 minus 7.5, there would be 5 boxes of cookies left over. And remember, we should always try that. If we have a final answer, always try to make it stand out. And on to page 4 of our notes.